What volume of Cl2 gas measured at 650 torr and 25 degrees Celsius is required to form 17 grams of NaCl? The reaction is given below. 2 moles of Na plus 1 mole of Cl2 forms 2 moles of NaCl. So to answer this question, we must do first the following conversions. So we need to convert 17 grams of NaCl into moles of NaCl, and from moles of NaCl, convert that to moles of Cl2. So starting with 17 grams of NaCl, to convert that to moles, we need the molar mass. So 1 mole of NaCl weighs 58.44 grams. Grams of NaCl would cancel. We are left with moles of NaCl. Then if you convert moles of NaCl to moles of Cl2, you need to use the chemical reaction given. So according to the chemical reaction, 2 moles of NaCl requires 1 mole of Cl2. So you plug that into your equation. 2 moles of NaCl requires 1 mole of Cl2. So moles of NaCl would cancel and our unit would be moles of Cl2. And if you solve this equation, you will arrive at the answer approximately equal to 0.1454 moles of Cl2. Now that we have the moles of Cl2, we will use the ideal gas equation to find the volume of Cl2. So the ideal gas equation is PV equals nRT. So if you want to find the volume, divide both sides by pressure. Pressure would cancel on the left side. And your formula is volume is equal to nRT over P. Now we know that N is equal to the moles of gas. We solved that earlier, 0.1454 moles. R is the gas constant, which you should be familiar. This is equal to 0.0821 liter atmosphere per mole Kelvin. T is the temperature, and the unit must be Kelvin. So you need to convert the given 25 degrees Celsius into Kelvin. And how do you convert degrees Celsius to Kelvin? You add 273.15. And this is equal to 298.15 Kelvin. And P is the pressure, and the unit must be in ATM. So in the problem, the given pressure is in torr, 650 torr. So we need to convert torr into ATM. So 650 torr. We know that 1 ATM is equivalent to 760 torr. So torr would cancel. We have ATM on top. So 650 divided by 760, that is equal to 0.855 ATM. So now that we have all the values, we just need to plug this into the equation for volume. So volume is equal to N, 0.1454 0.054 moles. R is 0.0821 liter ATM per mole K. Temperature is 298.15 Kelvin. Divided by pressure is 0.855 ATM. So if we check for the units, moles will cancel, ATM will cancel, and Kelvin will cancel. We are left with liters, which is the unit of volume. So if we solve for volume, the answer is equal to 4.16 liters. And this is the answer to the question.